So what is error? What is an error? Unexpected behavior. Here we are having a sender and a receiver. We are transforming data. So, for example, 101100 is the bit transmitted. Whether the receiver knows it is correct or not. Receiver will take the data. It does not know whether the data received is correct or not. So, we use error detection to identify the errors. Whether the received data is correct or not. So we use different techniques. To detect the error. First is going to be parity. First is parity check. Second is checksum. And the third one is CRC. In our unit, we have only parity check and CRC. So, we will see what is parity check. So, parity means we are going to add an extra data to the data which is going to be sent. We have a data, we are going to add an extra data to the data. In this, we have three types. One is going to be simple parity check, LRC, and two-dimensional. So in the parity check, we have three types. One is going to be simple parity check, the other one is LRC, and the third one is two-dimensional. So first we will see what is simple parity check. So the sender is going to send an data. It may be a single bit. So the data which we are going to send, we are naming it as data word. It is going to be of k bits. How will the data be transmitted? In what form it will be? 0 and 1. So it is going to be of k bits. And to send to the sender, receiver, we are going to add a code word. This is called, the original data is called as data word, and the data which the sender receives is called as code word. Why we need to change that? Why we can send as it is right? Why we need to change the data word to code word? Yeah, to achieve the error detection, to check whether the data is error or not. So it is going to be of k bits, and the code word will be k plus 1, which is equal to n bits. So k is the value of your data bit, and 1 is going to be here. It is your parity bit. 1 is going to be your parity bit. But here we have only one condition to add the parity bit. So parity bit will be either 1 or 0. But the condition is to, if the data word has 1101, how many number of 1 is there? 3. It is odd or even? We should make the code word even. The number of 1s in the data word should be even to make it as code word. Are you able to Your data work has 3 ones in this. It is either odd or even. Odd. The code word should have even ones. Even number of ones. Then what will be the parity bit here? 1. So this is going to be your code word. Can you understand? No. See, yeah, a data word. What is your data word? 1. What is your data word? Generally, what is data word? What we are mentioning data word? The data which the sender receives. What is going to be your code word? What the receiver receives. So, here, for example, we have the data word 1100. We have to convert this to code word. How will we convert? We are going to add a parity bit, which I have mentioned here. We are going to add a parity bit. Parity bit will be either 1 or 0. So now, this is where we are going to add your parity bit. The only condition to convert it to a code word is the number of ones in the code word must be even. If I am adding 0 here, how many number of ones here? It is even or odd? The condition is achieved. If I am adding 1 here, it is not even. So the condition is not achieved. Code word should have even number of ones. That is the only condition in your simple parity check. This is going to be your sender side, and this is receiver. First, your data word will be sent. Data word will be sent, and here you will have the code word. For example, we have 4 bits. You will have a generator here. Generator is the one which generates the parity bit. Generator is the one which is going to check whether the parity will be 0 or 1. And it will be 0. And then the data is going to be transmitted to the receiver. The receiver will have the code word, and you have a checker here. You have the checker here. What is the role of the checker? To detect the errors. See, checker will give a syndrome. And your data will be transmitted. So now, this is your code word. This is going to be your code word. This has error or not? Error. How you are saying this has an error? That's what. This is going to be a simple parity. What will this syndrome generate is? It will generate a 1. If syndrome generates 1, it is going to be error. If syndrome generates 0, then we have no errors. How will this syndrome generate? It will count the number of ones. Can we move to the next technique? Any doubts on this? Next is going to be longitudinal redundancy check. We have seen what is redundancy in the previous class. What is redundancy? We have seen in the previous class. extra data. So now here we have a disadvantages in your simple parity check. For example, this is your original data. This is your original data and this is your code word. Am I right? This is your original data, that is your data word, and this is going to be your code word. This has an error or not? No error. If I have 1 year, it has error. If I have 1 year, no error. But this is the original data. It is not the original data. The data is changed. So if more than 1 error is occurring, then this does not work. Then your simple redundancy check will not work. So we are moving to longitudinal redundancy check. So in this your data will be in the format of tables. Here you can give n number of bits. This is your transmitted data, for example. Okay. Here you have more than 8 bits, more than a single block. Now we will be writing this in the format of table. For example, this is your original data and we are writing this in the format of tables. Now what are we going to do is, for every column we are going to add a code word. We are going to add a parity bit. So 1, 1, 1. What will be the parity bit here? 1, 1, 1. What will be the parity bit here? 1. For next one, 1. For next one, 0. For third one, for fourth one, 1. For this, 1. This will be your code word. Now how the data will be transmitted here? The data that is going to transmit here is 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, and then 1, 1, 0, 0, 1, 0, 1, and at last your code word. This will be set as a separate bit. 1, 1, 0, 1, 1, 1, 1. This will be the data that is being transmitted. Here for each row you will check. The receiver checker will check each row. If any one is changed, if here we are having 1, then automatically this will not be changed. This will also be transmitted. Here previously we had here 1. If this is changed to 1, is there an error in this part? That error is in the fourth one. So error will be automatically detected. So if you are having error here, both the data bits are changed, but your code word is not changed and your even number of ones. Here the disadvantages is that if the same rows have, the same here columns have even number of bits changed, then you cannot detect the errors. Can you understand? See. So this was your first data which you are going to send. Here, if 1 comes, here the error occurred and the bit is changed. This has an error or not? How will you find this as an error? Odd number of ones. Here I have 0. Now 2 bits are changed. 2 different errors occurred in two different columns. And also here the number of one is odd. So error occurs. We can find two or more number of errors which occurs in different columns. If here I have an error, then this will be odd number of ones. Here also we can find it. But in the same column we have another one error. In the same column we have another one error. We will have even number of ones only. So that is the drawback here. Now can you understand? If even number of errors occurs in the same column, error cannot be detected. That is the drawback in longitudinal redundancy check. Can you move to the next topic? Can you move to the next topic? What is the third one? Third technique. To the parity check. So in this also in the same way, you will be writing your data in a table format. It will be in the form of rows and columns. But in the longitudinal, you only calculated it for your columns. Here you will calculate the parity bit for your rows also. So now how will you write? In the form of now tell me the parity bits. First one will have, second one, third, fourth, fifth, now you have to calculate the parity bit for your rows also. Here what will I have? Here 0. Automatically your column and your row is tallied here. Now how will you set the data? This is your code word. Sorry, this is your message. Now how will the data be transmitted is 1, 0, 0, 1, 1, 0. You will add this 0 also in your data that is going to be set. In your longitudinal, you will not have this row bits. Now you will be adding this also to your original data. Then what will be your second data? 1, 1, example, here your data is changed. You can detect the error or not. You can detect the errors. Where all you can detect the errors here? Here odd number of ones, and here also you have odd number of ones. If one data is changed, you can detect it in the two places. Here also you have odd number of ones, and in this row also you have odd number of ones. If it is changed here, it is changed to 0. Where all can you detect the errors? Here your bit is changed. Already here your data is changed and it is 0. Here again your data is changed. Then where all can you find the errors? In this row can you find the error? You cannot find here error here. Can you find error here? So if two bits are also changed, you can find the errors. For example, here your data is changed to 1. Can you find the error here? In this, you cannot find the error. Why? In this row, can you find the error? You cannot. 1, here 1, and here is 1. This is your original data 0. Already 2 bits are changed. Now your third bit is also changed. Here error occurred and it is converted to 1. Where all can you find errors? You can find errors here because odd number of ones, and in this also you can find errors as here odd number of ones. So more than 2 bits or 3 bits also change, you can find the errors here. In this 2-dimensional parity check, but we have a disadvantage in this. See, already 3 data are being changed. Your receiver got 3 data which are wrong. Now here it is also changed, and here also it is changed. Can you find the errors in this row? Can you find the error in this row? Can you find errors in this row? No. Oh yes, wait. All are 0. Only 2 is 0. Even number of ones is here. In this can you find them? So here you cannot find the errors. In this can you find error? Because here also it has even number of ones. Can you find error in this row? Yes. You cannot find error here also. In this row? Can you find error? Here you cannot find error. Here you cannot find error. Here also you are not able to find error. In this? No. So that is the drawback here. If 2 positions of a column is changed, then you cannot find the errors. So in this column also 2 positions is changed, and in the other column the same 2 positions are changed. Then you cannot find the errors in this. Can you understand? If two bits are changed in the same row, so same column, and in the same position, in another column the same 2 bits are changed, then you cannot find the errors. So this is the drawback in 2D parity check. So this is all about your parity check. What are the parity checks here? This is all about your parity check. So these all So to overcome all these drawbacks of parity checks, we use CRC, which is going to be cyclic redundancy check. CRC is called as cyclic redundancy check. Here the factor we use is polynomial. Cyclic redundancy check. So the data will be in the form of polynomials. What is polynomials? So this is the format of polynomials. So here we have sender and the receiver. So you have the data word and you form a here you have the generator and then here you have your CRC and the data will be transmitted and you have a checker here and your code word will be transmitted. But what plays a role here is your device. Whenever you are going to check with your CRC, you will have your data that is being sent and in addition to that, you will have an extra word, extra bit that is generated and we say that as generated function. So that plays the role of divisor. You can understand this and giving an example. So in the CRC, you will have a data word and a divisor. So with the help of that, we will be able to find your CRC and that CRC will be added to your data word and send it to the receiver. And again there revision happens and you will know whether the error occurred or not. So here revision plays one of the role. In this all those drawbacks will be detected. If you have same row, in the same rows you have same column also it will be detected. So now write a question. Suppose the following data blocks. Suppose the following data blocks are received. Where 2D parity is used. Suppose the following data blocks is used. Received where 2D parity is used. So the data box is going to be so this is your data blocks that is received in the receiver side. Check whether error is detected or not. You have error in this blocks or not. Check it out. So there